This is a solution for AB Calculus 2010, Form B, number 6. Looks like we've got some one-dimensional motion going on here. So, got this particle P, I've got its position, and this particle R got its position function. So derivatives of those would be velocity, second derivatives would be acceleration, and all that. Alright. So for times 0 to 6, find all times t during which the particle R, that's this one, is moving to the right. Moving to the right is the same as having a velocity, this is particle R, greater than 0. Right? Okay, so I'm going to call this V sub R, just so I don't get it confused with the other one. The derivative of this, 3t squared minus 12t plus 9. And to find where it's moving to the right, I need to know where it's positive, so I'm going to find the zeros and make a little sign chart. So it looks like I can factor a 3 out of that. Sometimes you have to do a little bit of math in calculus class. And factor that. It's just such a sad story here when the calculus here is so easy and you can't factor something like that. Tears. Just going from 0 to 6 here. So it looks like 1 and 3 are the turnaround points. And when I plug in something down here, I get positive. And in between here and here I get negative. You can plug in 2, for example, into this, you get positive. 2 minus 1 is positive. 2 minus 3 is negative. All I care about is signs here, not what the actual number is. And then it gets positive again. So, where's it moving to the right? Moving right on the interval from 0 to 1. And from 3 to 6. Alright, part B. For those times between 0 and 6, where are the particles traveling in opposite directions? Well, I know about particle R, so let's figure out the other one. So this one, derivative a little bit more tricky. So the derivative of cosine is negative sine of pi over 4t, and then the chain rule pops out of pi over 4, so pi over 4 times 2 is pi over 2. So that is the derivative. And we'd like to know, just like we did here, we'd like to set that equal to 0. And of course that doesn't matter, so because this is multiplication, so this is going to have to be 0. So when the sine of something is equal to 0, so that something here, if you think about the sine function, what makes it equal to 0? 0 does, or pi does, or 2 pi, or 3 pi, so on. So let's just figure out which ones of these are going to give us things in between 0 and 6. So if I multiply both sides of this by pi over 4, I get t is equal to 0. Multiply this by, multiply by 4 over pi, because I'm trying to get rid of it on this side. That'd be 0, 4, and then the next one would be 8, and so on. But I don't care about these, because they're outside of my 0 to 6 interval. So just 0 to 4. So if I make kind of like a double velocity sign chart, velocity of r, which I already did here, and velocity of p, both on it, that's what the r one would look like. And then this is a negative sign in front of here, so instead of going positive first and then negative, it goes negative first and then positive after 4. So it looks like we're going, what do we want? Opposite directions? Opposite directions. It looks like we have opposite directions here, while this one's positive and this one's negative. Doesn't matter if you do open or closed intervals on these. And let's see, opposite directions, also 3 to 4 right in here, because this is negative and this is positive. Alright. Part C. Find the acceleration at time 3 of particle p. That's this one. Is particle p speeding up, slowing down, or doing neither at time 3? Well, we know that speeding up and slowing down is just whether or not the sign of the velocity and acceleration are the same or different. Signs are the same, then it's speeding up. Signs are different, and slowing down. So, let's see, the acceleration of particle p. That is equal to the derivative of this. So taking the derivative of that, derivative of sine is cosine, so the negative sign stays, and another pi over 4 pops out. That's pi squared over 8. That's cosine pi over 4t. Okay, so I need to know what's the acceleration at time, what did they say, time 3. So if I plug 3 into this here, that is a cosine of 3 pi over 4. The cosine of 3 pi over 4 is the x-coordinate at 3 pi over 4, which is negative square root of 2 over 2. Which is positive, right? Negative times negative. And then the velocity at 3, we could find what it actually is, or we could just look at our sign chart, and I know that it is negative. So, since those two signs are opposite to each other, that means we're slowing down at time 3. And by we, I mean particle p. Alright, and then last, write but do not evaluate an expression for the average distance between the two particles on the interval 1 to 3. Okay, so I know how to find the average value of something using calculus, right? That's where you do the integral and you divide by how wide the interval is. So if I can make a distance between them function, then I can just find the average value of that function on this interval. So the distance between them is just the position of one minus the position of the other. But distance is a positive concept, always. Sorry, I'm pointing to something that's off the screen that you can't see. There we go. Distance is a positive concept, right? How far from school to my house? 15 miles. How about my house to school? Distance is still 15 miles. So I want this to be positive. It's the positive difference between those two. And then if I want the average value of that, average value of the distance, or in other words, average distance, that's equal to the integral from, let's see, what are we interested in, 1 to 3 of my distance function, divided by how wide the interval is, 3 minus 1, or you know what 3 minus 1 is, right?